On my screen, the equation represents a quadratic function in two variables with a cross-product term c times x times y. It is a quadratic function in standard form for two variables and represents a quadratic surface in three-dimensional space. The types of this surface depends on the coefficients a, b, and c, and the function can represent various shapes such as the ellipsoid surface when both a and b have the same positive or negative side. The hyperbolic paraboloid surface when a is positive and b is negative, and vice versa. The C influences how the quadratic surface responds to changes in both x and y. If C is larger than 0, it tends to make the surface tilt or be stretched in one direction, where if C is smaller than 0, it tilts in the opposite direction. The magnitude of C determines the degree of tilt or stretching. In summary, C affects the orientation and shape of the surface by introducing a class term that accounts for the interactions between x and y variables. The coefficients d, e, and f in the quadratic function contribute to the position of the quadratic surface in three-dimensional space. The term dx shifts the surface along the x-axis. The term ey shifts the surface along the y-axis. The constant term f represents a vertical shift along the z-axis. These three coefficients influence the position and orientation of the quadratic surface in relation to the coordinate axis. The simulated 3D surface plot in Power BI also allows us to rotate this quadratic surface and view its shape changes by different angles dynamically.